to the Agricultural Information Systems Group in Biological Systems Engineering at UNL. Here you would have hands-on experience on a complete workflow of data generation, gathering, processing, analysis for actionable decision-making in crop and rangeland management. So a primary data source for us are the data generated from drones or UAVs, stands for unmanned aerial vehicles. We use them to monitor the status of the plant growth in field. Everyone in our group would become a certified remote pilot by Federal Aviation Administration, which means you're legal to fly drones for research and commercial purposes in most of the cases in the United States. There are different types of drones. What you're looking at now are those multi-rotary ones. They are stable and nimble to fly, perfect for learning and research. These Hexer rotary ones actually have been working for us for 4 years under different environmental conditions without a single crash so far. It absolutely deserves a service medal. So in order to generate useful data for precisely and accurately monitor the plant growth status, we would use a series of sensors on the drones.
So this is a Phantom 4 ADA-TCAM drone. It has RGB camera, and it provides us the image with a natural color. It's the same image that our own eyes sees, and it follows the same principle as our smartphone. This drone have a wide range of application in agriculture, and it can help us recognize weeds from the crops. The image taken by this particular drone with ADA-TCAM GPS can achieve up to a centimeter level of positioning accuracy, which allow us to pinpoint the hotspot in the field.
This one actually is an integration of two types of camera, the multispectral camera and the thermal camera. The multispectral camera is specialized for the vegetation sensing to detect the core field sectors, and the thermal camera is known to be a good way to detect if a plant is under a drought stress. These two types of cameras are widely used in crop and rangeland management to monitor the biomass and the quality of forage production in pasture.
So what carried on this drone is a LiDAR scanner and a hyperspectral imager. So the LiDAR scanner can be used to measure height and shape of the canopy, and the imager is just a great research tool to help us distinguish vegetation stresses. And what we are using right now is to use the hyperspectral imager together with other sensors like the thermal camera or the other camera to distinguish crop water and nitrogen stresses.
Besides the aerial images, other data we typically collected is the canopy cover or leaf area index, which is representative of the plant size and the density, as well as the leaf stomatal conductance, which is the proxy of plant water stress level, soil moisture, and the nutrient level, and weather and management information.
Yeah.
That's all.
Instead of manually downloading and storing the data, we are trying to gather the data automatically from different sensors at different locations using the agricultural Internet of Things. Some of the data will be directly uploaded to and processed at the cloud. Some of them will be processed locally where they are generated.
Having the data is not enough. We need to work on this data for having some help in the agricultural purposes. In our group, we make use of physical-based models such as crop growth models and data-driven models like statistical and machine deep learning models which helps in getting and procuring information that could be used for actionable decision makings. Some examples of these decision makings are to keep a check on the timings and the applied quantity of the fertilizer and the irrigation applications in the fields, and for the drone applications in the fields that are used for spot spraying.
If you're interested in technologies and passionate about developing engineering solutions to help feeding the world, biological systems engineering is the place for you.